Somewhere out past the orbit of Neptune, and also on a moon circling Saturn billions of kilometers away, something is sitting quietly on the surface that apparently does not match anything scientists have ever recorded before, and right now, nobody can say exactly what it actually is. If this sounds interesting to you, go ahead and hit subscribe right now, because we cover strange discoveries just like this one every single day. So let's start with the basic setup, because this story involves two very different worlds that turn out to share something surprising. One of them is Pluto, the frozen dwarf planet way out in the Kuiper Belt, spinning quietly about 40 astronomical units from the Sun, wrapped in an atmosphere so thin it barely counts as one. The other is Titan, the large icy moon of Saturn, a place with rivers, lakes, and an atmosphere that is actually thicker and denser than Earth's, something that is unusual for any moon in our solar system. These two places are billions of kilometers apart, sitting in completely different neighborhoods of the solar system, orbiting completely different kinds of parent bodies, and yet, in a recent study, astronomers apparently found a very specific spectral feature showing up on both of them, something that seems to link these worlds together, and more importantly, something that appears to come from a material science has apparently never identified before. Using the incredible sensitivity of the James Webb Space Telescope, a tool built partly to peer at exactly these kinds of faint chemical signals, researchers detected this strange, unidentified substance sitting right on the surface of both worlds, and that is the mystery we want to walk through today, along with some ideas about what this substance could possibly be, why it seems to show up on two such distant places at once, and why any of this seems to matter for how we understand the wider solar system. Now let's slow down for a moment and talk carefully about what the researchers actually found here. A team led by Bruno Bizot at the Paris Observatory recently published a study describing this discovery, and apparently it is available for anyone curious enough to go read the details themselves. The team was working with data from the James Webb Space Telescope, focusing mainly on two instruments called NIR-SPEC and MIRI, which are built to observe near-infrared and mid-infrared light, essentially letting scientists see wavelengths our eyes could never pick up on their own. In that data, they noticed a very specific dip in the light, reflecting off the surfaces of both Titan and Pluto. When you see a dip like that in astronomy, it is usually called an absorption feature, and it basically means something on the surface is soaking up light at a very particular frequency, which creates that dip in the spectrum. This is actually one of the main ways we figure out what distant objects are made of without ever visiting them, since every material seems to leave a slightly different mark on the light bouncing off it. In this particular case, the dip showed up at a very specific wavelength, around 5.11 micrometers, and it represented an absorption of about 6 to 7%, which might sound small, but is apparently more than enough for researchers to take seriously. The researchers determined that this signal was coming from something solid on the surface of each world, not from the atmosphere, which matters because every known chemical compound tends to leave its own fingerprint in the light spectrum. Molecules like carbon dioxide, methane, and oxygen each absorb light in their own specific pattern, almost like a chemical signature, and scientists use that pattern to identify them from far away. For example, when we look at the atmosphere of Mars, the absorption pattern tells us there is a good amount of carbon dioxide, a little water, and a small amount of carbon monoxide, and the deeper the dip, the more of that material seems to be present. By studying compounds here on Earth and creating similar absorption patterns in the lab, scientists can then compare those patterns to what we observe on other planets and moons, and that comparison is usually how we know what is actually out there without ever sending a spacecraft to check directly. Up until now, both Titan and Pluto have shown fairly familiar absorption patterns, mostly confirming large amounts of methane, a good deal of nitrogen, and traces of carbon monoxide, so nothing too surprising, at least until this particular signal showed up. And even though Pluto and Titan seem quite different at first, they apparently share a surprising amount of chemistry. Pluto is small, cold, and has an extremely thin atmosphere, apparently around 15,000 times thinner than Titan's, while Titan has a dense atmosphere with actual liquid on its surface. Despite that difference, the chemistry of their atmospheres looks remarkably similar, since both are dominated by nitrogen and methane, with Titan's atmosphere being a bit more complex overall. Because of this shared nitrogen and methane mixture, both worlds experience something unusual, which is that sunlight hitting these gases apparently triggers complex chemical reactions that produce a kind of organic haze, and this haze is much more noticeable on Titan than on Pluto. Some of this haze eventually freezes and falls down onto the surface like a strange kind of snow. On Titan, recent studies suggest this organic snow could be anywhere from a few centimeters to around 1 meter thick, forming a soft, fluffy layer sitting on top of the water ice underneath, almost like Titan is quietly buried under its own snowfall in certain regions. Something similar seems to happen on Pluto, just on a much smaller scale, and researchers think this shared atmospheric chemistry is very likely the reason we are seeing the same mystery compound show up on both surfaces. But here is where things get even more interesting, because the way this substance appears is not identical on both worlds. On Titan, the absorption feature looks fairly narrow and fairly sharp, while on Pluto, that same feature is roughly 3 times wider and more spread out, which raises an obvious question about what exactly is causing that noticeable difference between the two. Right now, the most likely explanation seems to involve the physical state of the compound itself, rather than the compound being entirely different in each place. Pluto's surface is exposed to far more cosmic radiation than Titan's, mostly because its atmosphere is so thin that it offers very little protection, and that radiation apparently breaks apart chemical bonds and disrupts the molecular structure over time, which could broaden the signal and shift the overall composition of whatever sits on the surface. Another possibility is that the size of the individual grains forming this snow is simply different between the two worlds, which on its own could also change how thick or narrow the absorption line ends up looking. And there is a third possibility worth considering, which is that this material is mixing with something else already present on the surface, producing a slightly different compound with a slightly different texture in each location. Interestingly, though, in terms of color and general appearance, the two seem to look basically the same to observers, even if the underlying signal is not. As of right now, in the middle of 2026, nobody actually knows what this substance is. Even after comparing the signal to thousands of known chemicals across major databases, including ices, hydrocarbons, and complex organic molecules like tholins, which are the reddish compounds that give Pluto part of its color, none of these were a perfect match. But researchers do have a few candidates worth considering. One possibility is a group of organic compounds with a 3-carbon chain, which apparently do absorb light somewhere in this general range, though not perfectly enough to be a confirmed match. Another option is some kind of benzene mixture, since benzene has already been detected in Titan's atmosphere before this study, and while pure benzene on its own does not match the signal, a mixture involving benzene combined with something else might. A third candidate worth mentioning is ketene, another organic molecule that shows a fairly weak signature somewhere near this particular wavelength, though again, not an exact fit. The lead researcher apparently mentioned that whatever this substance turns out to be, it is likely to surprise everyone once it is finally identified, mostly because this does not look like a simple pure substance, but rather some kind of complex mixture of different organic materials layered together. So why does any of this actually matter? Well, this is not just about finding some strange kind of alien snow sitting on 2 distant worlds, even though that alone is a pretty fascinating image to sit with. Titan in particular is considered one of the most promising places in the entire solar system to study what scientists call prebiotic chemistry, meaning the kind of chemical processes that may have happened here on Earth before life ever actually began. Understanding what these solid materials and molecules actually are tells us something important about how far chemical complexity can go, even on a moon that is extremely cold, dark, and icy, far from any warmth of a sun. On top of that, NASA is actually preparing to send a mission called Dragonfly to Titan in the coming years, a nuclear-powered rotorcraft designed to fly from region to region across the moon's surface instead of staying in one fixed landing spot. Scientists are currently using this James Webb data to help map out the best possible landing and exploration sites for that mission, treating it almost like a chemical map of where to look first. If this mystery compound only shows up in certain geological regions, that could tell us something meaningful about how it actually forms, and it could also help mission planners decide which areas are worth exploring and which ones might be risky, especially if a spot turns out to be covered in a thick layer of this strange organic snow that the helicopter could potentially sink into or get stuck inside of. Meanwhile, back here on planet Earth, in ordinary laboratories, the researchers behind this particular study are apparently trying to recreate this exact 5.11 micrometer signal in lab conditions by testing different organic mixtures side by side, hoping to figure out the precise chemical recipe behind it. There is a real chance that scientists identify this substance before Dragonfly even reaches Titan, which would give us a much clearer picture of what is happening on both of these worlds, and possibly even hint at whether life, or at least the chemistry that leads to life, could exist there. And if that identification does not happen in time, Dragonfly is still expected to reach Titan by the mid-2030s, carrying a mass spectrometer on board that is capable of directly identifying these mysterious compounds once it actually lands on the surface. When you really sit with this for a moment, it is honestly remarkable what we can achieve with a single telescope, sitting millions of kilometers away from either of these worlds, simply by capturing one careful image and studying the light within it. From that distance, we can apparently detect specific organic materials sitting on a moon orbiting Saturn and on a dwarf planet even farther out near the edge of the solar system, something that would have seemed completely impossible to most people only a few decades ago. It is a good reminder that even now, with all the tools we have built, there is still so much left to learn about our solar system and about the sheer chemical diversity that seems to be quietly hiding almost everywhere we look, sometimes right in plain sight on surfaces we have already been studying for years. Once more data comes in from further observations, and once researchers actually reach some solid conclusions about what this substance really is, this is definitely a story worth coming back to and following further. For now, that is where things stand with this strange, unnamed substance drifting quietly on the surfaces of two very different worlds. One an icy dwarf planet at the edge of everything, the other a moon with rivers and lakes of its own, both apparently hiding the same unidentified chemistry, and both simply waiting for someone, somewhere, to finally figure out exactly what it actually is.